Hi, I'm Peyton Charlstrom, and I'm a Central Applications Engineer here at Analog Devices. Today, we're going to be examining the LT8641A step-down regulator, which features our trademark silent switcher architecture. Basically, I'm going to be measuring some of the key specs with our test setup that I have here. And so I'm going to demonstrate the part's wide input voltage range, low quiescent current, and then I'm going to show you the output ripple here on the scope. So let's get started. First off, so this part has a pretty wide input range going from 3.4 to 65 volts. And so here, with our power supply, 12 volts going to the input of the board. And here we have our electronic load set to 1 amp. Just looking at our digital multimeter here, with 12 volts in, we are getting approximately 5 volts on the output, just as expected. Just to prove to you that it will do this at any voltage within the input range, I'm going to increase it to the maximum that this power supply will go, which is 60. There we go. That's 60, 5 volts on the DM. Well, I guess before we move ahead, I do want to mention that I'm running this board at 2 megahertz, which allows us to get about 94% efficiency, but you can adjust the frequency from 200 kilohertz to 3 megahertz. And this is important because higher frequencies allow us to use smaller magnetics, which reduce cost and solution size, given that the magnetics are take up the most space compared to the other things on the board. And on the other hand, we can reduce the frequency and have higher efficiency at the cost of larger components. So really, it's up to you and what you want to prioritize. So moving on, we're going to take a look at this guy here, our benchtop multimeter. I'm going to show you the quiescent current. And to do that, I'm going to disconnect the load, and we're going to see how much current the board is drawing when we have no load. So I'm going to turn that off. Okay. Disconnect the wire. And also put this back to 12. 12 volts. If we look here, this is in milliamps. So we got 0.00 and then a couple numbers. But if you average that out, it is definitely less than 10 microamps. The next thing I want to show you is the very low output ripple that this part is rated for, which should be less than 10 millivolts peak to peak when we look at it here. So let's reconnect our load and put that back at 1 amp. So let's plug that in again. That 1 amp load here. Okay. So we're back to 5 volts out, 12 volts in. And now bring your attention to the scope over here. So what I've done is I've removed the tip from this probe here, and I've attached a ground spring to reduce the ground loop to get a more accurate measurement without interference. So what we're going to do is put this across the output capacitor. And so draw your attention over here. It's a little bit finicky, so it might take a second. Okay. So there we go. We're going to capture a single of that there. Okay, fantastic. So, if you look here, I have a peak-to-peak measurement that I had already set up, and we can see that it is 6.32 millivolts peak-to-peak, which is less than 10. So that checks out. So, that's it for the bench measurements that we were going to do today. But before I wrap up the video, I just want to mention that the 8641A that I have here, as I mentioned, it is part of the Silent switcher product family. And what that means is that it provides ultra-low EMI emissions, making it ideal for applications where, performance is critical. And this also makes it easy to pass the CISPR standards, which are required in certain industries. For more information about the part, you can check out the product page where you'll find the datasheet, simulation models, and the eval board along with the user guide. And if you have any technical inquiries or questions about a part, you can always contact our support team through the link below. Or you can always use the Ask a Question button on the LT8641A product page. Thanks for tuning in, and we'll see you next time.